Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything. We can write the requirements for it.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
The X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
The sun would first stir life on our planet. Gradual shiftings and upheavals would bury creatures and plants beneath the surface of the Earth. There, they would fossilize, eventually turning into huge reservoirs of gas and coal.
Oil made possible one of the greatest inventions of history, the internal combustion engine, which gave us mastery over the air.
Pollution grew around us, until one day, at last, we noticed that something had gone wrong with our once pretty world. Just in time, the satellite now gives us a view of pollution impossible to get in any other way.
Scientists and researchers continue to develop various technologies to cut fuel consumption through aircraft structure and engine design.
Lightweight wires and electronics replace mechanical linkage.
NASA researchers see vertical takeoff aircraft as commercially useful. These types of aircraft use less room for takeoff and landing and keep noise and air pollution lower than our present commercial planes.
One of the most unusual and highly experimental aircraft ever tested at Dryden was the Gossamer Albatross. The Albatross was human-powered and pedaled like a bicycle. The man who designed the Albatross also built the Gossamer Penguin, the world's first flight-worthy sun-powered plane.
ERAST is NASA's environmental research, aircraft, and sensor technology program, and its mission is to develop aircraft that are capable of flying very high and very slowly, primarily to do atmospheric sampling and monitoring of the global environment.
Solar power offers some unique capability for flying in the stratosphere.
The Helio should be able to stay aloft for up to 6 months at a time to function very much as an atmospheric satellite.
What's very unique to the solar-powered airplanes is that they are not polluting the very atmosphere that they're trying to take samples from, so they're ideally suited for that purpose.
These vehicles can help us attain a desirable balance between technology and nature. The stakes are high as we speed toward a challenging future.
Solar-powered aircraft don't really work well at nighttime. This is a way of compensating for the inability to get energy at night. The airplane flies off the energy provided by the laser.
This is the world's first demonstration of the application of laser energy to a flight vehicle to achieve truly fuelless flight.
NASA Aeronautics continued its green aviation initiatives. Their goal? To make air travel quieter, cleaner, and more efficient.
while increasing the safety and comfort of passengers.
With this mandate to significantly lower noise and emissions and increase performance for subsonic aircraft, there will be a need to address virtually every aspect of the current aircraft configuration.
We're using a blended alternative fuel to evaluate the impact of different fuels on the emissions of the aircraft.
People have done life cycle studies to look at the carbon balance, which takes into account the amount of energy that you use in growing the plant, processing the oil. Some of the studies have shown about a 75% reduction in the amount of CO2 that you get using camelina compared to a conventional petroleum-based fuel.
NASA started investigating alternative fuels as a way of reducing the carbon emissions from aircraft, but there's other benefits of these fuels. They produce much lower levels of soot, and also they do not have sulfur contaminants.
Hopefully there will be a fairly significant return on the investment in terms of improved public health and environment.
Everything within subsonic aviation now is looking for efficiency. We're looking at structures to make aircraft lighter. We're looking at various propulsion systems in order to make them more fuel efficient, and we're looking at configurations to lower the noise impact of community noise, essentially looking at an environmentally responsible aircraft.
We really think this airplane is revolutionary. It's a big jump in technology from the tube and wing kind of airplanes that you see today. It's much more efficient. I like to say it's like a hybrid car compared to a regular car.
It's exciting to think that we're contributing to the green aircraft of the future.
The aircraft now can be programmed to have, for example, engines that are more fuel efficient. Control the engines separately and also more closely and carefully.
This is NASA's first all-electric crewed aircraft.
We can use electric propulsion systems and aircraft design in an interactive way. The wing itself is designed so that the electric motors enable extra efficiency in the wing itself.
There's several different types of airplanes that can benefit from electric propulsion. The one that's gaining a lot of interest right now is the smaller version, the air taxi type vehicle.
In doing the work of developing these systems, integrating these systems and so forth, we have helped industry along their path.
We've been able to deliver lessons learned on batteries, on how you do the power electronics, how you build up the motors. And so X-57 really has been a pathfinder early on for electric propulsion.
Next generation of vehicles, they're going to be much greener and much more efficient types of propulsive technology.